Mr. Goody's like, I'm a girl.
Okay, now if I read, I'm for real, y'all.
Thank you, thank you, thank you. So let's talk about, I believe we finished 4. Let's talk about 5 really quickly. No, wait, hold on. Yeah, when you dragged one of the vertices and observed the changes, did that change whether it was congruent or not? Rin?
No, because, hold up. That's what I changed my answer because the area angles are also congruent.
Okay. Even when you changed that triangle, it stayed congruent, didn't it? With the reflection, okay? So when you change the line of reflection, here in number 6, and observe the changes in the reflected image, were the images still congruent?
Yes.
Yes. And so we want to notice, it doesn't matter whether you change the triangle or you change the line of reflection or anything like that, those images stay congruent. So this is where we really need to pay attention and take some good notes. So an isometry is a transformation that produces an image that is congruent to the pre-image. Is a transformation using reflection and isometry? Yes. It did not matter what the line of reflection was. It did not matter what the triangle was. The pre-image and the image were always what? Congruent. The pre-image and image were always congruent. They could map, or one could map to the other. You need to make sure you have that down or something equivalent to that. So, with a translation, were triangle ABC and triangle A prime, B prime, C prime, did they have the same orientation?
No.
With a translation?
Oh, yeah.
Yes. A translation, they had the same orientation. With a reflection, do they have the same orientation?
No.
No. Right? So when we looked earlier, B went to C, went to A, where B prime went to A prime, went to C prime, right? That's a different order. So different orientation. Does the shape or location of the pre-image triangle affect your answer?
No.
No. Right? It did not matter. It's always the same. So, never had the same orientation. And so this number 9 is the final thing we're going to focus on before we move to rotations. The properties that are preserved. Well, oh wait a second, it looks like some of us are still writing, which I appreciate. Okay? So what do we mean by preserved? They were kept the same, they stayed the same. So what was preserved? Were the side lengths preserved?
Yes.
Okay?
The side lengths, the angle measures, the perimeter, and the area.
Side length, angle measures, area,
And perimeter.
and perimeter. So what didn't stay the same?
The orientation.
That's the only thing. So not preserved. Orientation. In a reflection, the only thing that is not kept the same is the orientation. Everything else is the same, which makes sense because the images are what to each other?
Congruent.
Congruent. Those figures are congruent. So their side lengths, the angle measures, the area, the perimeter, all those have to be the same. The order that they're in just isn't, right? The orientation is not the same. In case you need that. So you should have a new file on your calculators. We can talk about it, but the main thing that I wanted y'all to learn was this. The other stuff was practice. If you got there, then you're going to be better prepared for the understanding checks and things like that. But those are the main things I need you to get out of this. Okay?
That's great.
And if you really look at it, all it was looking at the reflections that when you reflect over the x-axis, the y value is the opposite. When you reflect over the y-axis, the x value is the opposite. Okay? So what we're moving into, what I already sent you on the calculators, is the rotations portion. Claire, do you have any prediction about why we might call a rotation an isometry? So the pre-image and the image are always going to be what? Congruent. We haven't even done rotations yet, at least in this tag, in this task. But so far, every time we've done an isometry, the pre-image and the image have been what? Congruent. That's the biggest thing that we need to understand. But I don't want to just lecture to you. I want you to see that this is true. And so we're going to try to develop those generalized expressions, which we've already done that some. We're going to be focusing on why a rotation is called an isometry. And so, why did I skip numbers 1 and 2? Hold on a second. For some reason on my slides, I am missing a slide. That's my fault. Oh well. But you have it on this sheet. You have the task. So notice on page 1.2, this is where you should be looking right now. Right? It gives you the directions. Determine if a rotation of a figure changes the size or the shape of the figure. Right? Two figures are said to be congruent if they have the same size and the same shape. Move point P on the clockwise circle and observe the rotated image. Does the rotated image appear to be congruent to the pre-image? Why or why not? So work within your small groups. It's literally just exploring it on the calculator, moving the things around, follow your directions, and I will come by and see what questions you have. Let me know how it's going. We did some, but this is a little bit different than what we did in the past. Remember, we already did translations, reflections before the last two tasks. We're trying to learn something new out of these tasks. Have you done enough